I'm Anil Kumar sharing with you questions on linear application. Sam is walking at a constant speed in front of a motion sensor. After 2 seconds, he is 1.5 meters from the sensor. 2 seconds later, he is 4.5 meters from the sensor. Now, based on this, there are two questions for you. The first one is, find the equation that describes Sam's motion in the form of d equals to mt plus b. B is, what is the d-intercept and what does it represent, right? So let me first explain the scenario here. We could actually sketch the graph of this motion. So after 2 seconds, he is 1.5 meters from the sensor, and 2 seconds later, he is 4.5 seconds away, right? So basically, it's a linear graph, something like this equation d equals to mt plus b will be kind of like this, right? Where the independent axis will have t, and here the distance from the motion sensor, right? Units seconds for time, meters for distance. Now it says after 2 seconds he is 1.5 meters away. So let's say this is the position after 2 seconds, and this distance is 1.5 meters away from the sensor. 2 seconds later, that means, let's say 2 seconds later, that becomes the position, but the time will be 4 seconds, right? So at this time, 4.5 meters away. So this is 4.5, right? So let me break the scale here. So that is the position, right? Now it says, find the equation that describes Sam's motion in the form of d equals to mt plus b. So we have 2 points on this line, and from these 2 points we can always find the equation of the line. So let me write down the points which we have. So at 2, let me call this point as A, and let me call this point as B. So point A for us is at 2 seconds, distance is 1.5, and point B is 2 seconds later, means time is 4 now. The distance is 4.5 meters. Is it okay? So from here, we can find the slope m. Slope m equals to y2 minus y1 divided by x2 minus x1, right? That is the general formula. So anyway, in our case, we have these 2 points. We should not call them y2, y1, since we have d on the y-axis and t on the x-axis. So let me call these points in our scenario as d2 minus t1 divided by t2 minus t1. Is that okay? t2 minus t1, where the coordinates of any point P is t and d. Does it make sense? So we are trying to relate the variables defined here with general variables x and y, right? Since the x-axis is labeled as time in seconds and the y-axis is distance in meters. Is that okay? That helps you to answer the part B. What is d-intercept and what does it represent, right? So that is called the d-intercept. Let me say d-intercept. Now with this, I think concept is clear to you. You can pause the video, answer the question, and then look into my suggestions, correct? Okay, now let's begin to solve this. So first we need to solve or find this equation. We need to basically find what m and b are, right? So we are given 2 points. Let's use these points to find. So let's use this point 4 is time t and d is 4.5. So if I substitute point b, I get this equation as d is 4.5. So let me write 4.5 equals to time t is 4. So let me write this as 4 for t and m plus b. From point A, we could say 1.5 is equals to 2. That is the t value, time 2 plus b. So we get 2 equations, these 2 linear equations, correct? Now what happens if I do equation 1 minus 2? Let's do it. So now we will do equation 1 minus equation 2. So if I do that, on the left side, 4.5 take away 1.5 will give me 3 equals to 4, I'm sorry, this would be m, okay. 4m minus 2m is 2m, b minus b is 0. So from here we get the value of m, which is 3 over 2, or you could write 1.5, either way. Once we know m, we can substitute the value of m and find b, right? So first let me call this as my equation number 3, and now I will sub equation 3 in equation 2, right? In equation 2. So that is to say, instead of m here, I'll write 3 over 2, right? That makes sense. 2 will get cancelled, right? So you could write 1.5 also, either way. So what we get here is 1.5 equals to 2 times, I could write 1.5 also, it's okay, plus b, right? So b is equals to, this is 3. So taking on the left side, what we really get here is the value of b as 1.5 take away 3, right, which is b, and so b is equals to minus 1.5. Do you see that? So b is 1.5 with a negative sign. This is our equation number 4. Since we know what m and b is, we can write down our equations, correct? So let's write down our equation. So equation is d equals to mt plus b. What we really found was slope m equals to 3 over 2. Let me write 3 over 2 in fractions. And b is minus 1.5. So which is also minus, but 3 over 2. That is b. Let's write in fractions. It is always better. Okay. So substituting these values here, what do we get? We get d as equals to 3 over 2 t minus 3 over 2. That is what we get. So this value here, which is our y-intercept, actually is minus 3 over 2. So this diagram is good for explanation, right? But not really. It is not really matching with the given situation. So let me redraw this from the results which we have just got. So actually, strictly speaking, I should be drawing this as like this. So what we have here is minus 3 over 2 is like minus 1.5. So the graph is kind of like this, okay, where that is the d-intercept, right? So this is d for you, t, and this position here is minus 1.5. Do you see that? And at, we can say this is, let me now write, and let's say this is 4 for us, okay? So this is, let me change the ink. So this point is at 2, and then let's take this as 4, okay? And at 2 we have 1.5, and at 4 the distance is 4.5. Is that okay? So that is the scenario. So, and that's the diagram for you, right? So basically at 0 the person was on the other side of the sensor, right? It's moving in one direction, but that distance is supposed to be negative, the left side of the sensor, and the person moves right. So that's the scenario for you, okay? Now let's answer this question. What is the d-intercept and what does it represent? So here d-intercept is minus 3 over 2. You can also say is basically minus 1.5. Since the units are in meters, I should write meters here, is 1.5 meters. That means that Sam was 1.5 meters to the left of motion sensor, right? That is what it motion sensor at t equals to 0, right? So if I substitute t0, I get d values minus 3 over 2 or minus 1.5. That means Sam was to the left of the motion sensor when this measurement started, when t was equal to 0. I hope the concept is very clear to you, and that is how it could be actually solved. I'm Anil Kumar. You can always share and subscribe to my videos. Feel free to post questions. And if you like, put a like. Thank you and all the best.